Uh, Hello everyone, my name is Sandeep Chaudhary. I am a student from NIT Jalandhar. So today we are discussing a real world example of control systems, cruise controls in car. Imagine you're going on a highway where you want to set a certain speed and you just press a button called cruise control and that's it. You set a speed and then you can enjoy the ride. You don't have to accelerate every time. The speed will automatically goes at that set speed, no matter how the road goes uphill or downhill. So we will discuss how this control system application work. It was invented by Ralph Taylor in 1948, who was a blind engineer and wanted to maintain a constant speed without manual intervention. So he invented this cruise control system. So if we let's talk about the definition of cruise control system. Uh, A closed-loop control system that automatically maintains a vehicle's speed without continuous driver input. So, as we discussed earlier, we don't have to accelerate every time. It will automatically maintain the speed. So, before diving into the topic, just have some basic control system basic. So, open loop system and closed loop system. These are two types of systems in control system. First is open loop system, where we do not have any feedback mechanism, and what is the output is never dependent on input. So if we just take example of simple timer based systems where we don't have to look at the input side, and another type is closed loop system where we use the feedback for the correction. It is a self-correcting systems based on error. And if we talk about the example, obviously the example is cruise control, which we are discussing in this video. And another example of closed loop system is temperature control. So key element which we will use in this video is set point, which is desired speed, error, which is the difference. Error is basically the actual speed minus desired speed or vice versa, whichever you can. And third is controller, which is a ECU. Fourth is output, which is throttle adjustment. Uh, System block diagram of cruise control system, where we have that driver input. Driver will give the desired speed input, and then the ECU will process the error. The ECU will process the error by desired speed minus the input speed, and after getting that error, it will give it to the throttle actuator, which will adjust the engine throttle if uh, we have to maintain the speed. So fourth, we have the speed sensor, which measure the actual speed of car or any vehicle where we have to apply the cruise control. And the last is brake sensor, which helps in override or disable the signal. If we just take a simple example, you're going on a highway and you set a speed of 60 km per hour, and if we accelerate at that point, it will just accelerate and achieve some speed, for example 80. But when we uh, leave our feet from that accelerator pedal, it will achieve 60 again. But in case of brake, if we are going on a highway or any road, if we apply a brake, then it will disable that cruise control signal because it is necessary. For example, if we're going on a highway and some vehicle came in front of us and we applies the brake, and whenever we will remove our feet from that pedal, it is not good if it accelerate and achieve that desired speed. We have to disable that signal. Let's talk about that key components. Speed sensor. It actually measures the vehicle speed using the wheel rotation or transmission data. Second is the speed sensor will give it data to ECU. Then it will process the sensor data and compute total adjustment using control algorithms. Fourth is throttle actuator, which is a electromechanical device that adjusts throttle position to control engine power. Fourth, we have that driver interface, buttons and controls allowing driver to set, zoom, and cancel cruise speed. Fifth, we have brake, clutch sensor, uh, which is necessary as we discussed in the example of brake and accelerator over a cruise control. So, safety sensor that automatically disengage cruise control when brakes or clutch are pressed. Now let's have a step-by-step working of cruise control system. First, we set the desired speed. Like we are going on any road, preferably highway. We set the speed at 80 km per hour. We apply that, press that set button, and that's it. Then the system will measure actual speed of that car and it will continuously monitor that current vehicle speed. After that, the error got calculated. Error, which we have already discussed, desired speed minus actual speed. Then we have to process this error in the ECU. Uh, According to that computations which have been done in ECU, the throttle got adjusted by the equator, and that's it. This loop will continue over a time whenever cruise control applies. So it is a continuous feedback system. So system repeats cycles adapting to the road conditions uphill or downhill. PID controller inside a control cruise control. So let's talk about how this PID work in cruise control. So for P there is a proportional immediate response to current error. Yes, we have that response to that current error. It is proportional. And second, we have the integral, which is used to eliminate steady state error over time. Third, we have derivative, which predicts future error and prevents overshoot. This is the basic formula for PID4, where we have UT, that's equal to KP into E of t plus Ki integral E of t dt plus Kd d, a derivative of E t. This Kp, Ki, and Kd are tuning constant, and Et is a error signal. We have discussed about the cruise control. Let's talk about the adaptive cruise control, which uses some more advanced technology. For example, lidar sensors, which detects the distance and the speed of vehicles ahead, enabling automatic speed adjustment. Multi-loop control uses nested feedback loops for speed maintenance and vehicle following. Uh, Today we have some more advanced system. For example, Tesla Autopilot and Honda Sensing using computer vision and machine learning for enhanced safety. Okay. So there are always a pro and cons for any system. So let's talk about the advantages and the limitations of cruise control system. First, first advantage is fuel efficiency. It maintain the optimal speed and reduce fuel consumptions by 10 to 15%. Second advantage for cruise control is it provides a driver comfort, which reduce the fatigue on a long highway journeys. Third, we have safety. It prevents speeding and maintains safety distance. And let's talk about the limitations of cruise control. It is not for city driving, where we have to apply brake after few seconds or few minutes. So it is not recommended in city driving. Uh, no system can be fully reliable on machines. So there always be that chance of failure. So driver have to be alert so it can intervene in between the system. Third is weather dependent. For example, if we have the area where there's a rain, fog or snow, so the cruise control will provide a poor performance. And the main disadvantage that should be considered is cost. If we look into cruise control system, like if we take two cars, car is same manufactured by same company, same model, okay, and the second car is also manufactured by the same company, but the minor or maybe you can say major difference is cruise control. So the pricing of both the cars are so different. Cruise control car will actually high of the higher price and which will add expense to the buyer. Um, let's conclude this video. We have seen the real world implementation of closed loop systems. Uh, we u- we have seen how PID controller used for precise speed regulation. We have seen how the modern variants uses radar, lidar for adaptive controls, and we also discussed the example of cruise control which improves fuel efficiency and driver comfort. That's it. Thank you, everyone. Uh, that's it from my side. Sandeep Chaudhary from NIT Silver.